Hello, guys. Welcome for the session Java for Layman. So this session is going to be a very simple session, small session, a teaser session, where the goal is to talk on Java, not go into the specifics of Java, but for all the non-technical folks or the new folks who do not have an understanding of Java, this session would give them the benefit of starting with Java. I hope by the end of it, you will develop an interest of learning Java. The goal is to make it very simple. We will be talking about why Java came into existence, the different examples. We'll talk on different examples. We'll not go into the detail of Java. That is your job, but it is that starter where it would help you to go for the main course. Yeah, it will help you to develop interest on Java and not really have that fear of programming language, right? So, and we will see different examples towards that, and we also plan to do another session too, where we'll see how Java is used in MDM. All right, let us get started. So first of all, let us understand why Java came into existence, right? Let us try to understand a little bit of programming history. So way back in 1950s, it was all big computers, right? Even for you to do big small computations like calculator and all, big computers were used. You might have heard about that. Come 1970s, 1980s, you got the calculator, for all the scientific calculation and many things. You got the calculator, so small device, right? That is also a computer, where you could the hardware evolution was happening continuously, so where you could do a lot and lot of calculations, so simple mathematics, algebra, and then your calculus functions, your trigonometric functions, your scientific functions, all started coming onto the calculators. And then in 1980s, with Bell Laboratory bringing in the C, and there are few other programming languages which had happened, but most of us know about the C language, right? Which got very famous in 1982 and all. Yeah, and then come 1990s and 1995, something called C++ became famous because of the OOPS concept. We'll understand what is that. And come 2000, it was all big bang, right? Java became very famous, and it is indeed famous now also. Okay, so we'll try to understand all of this. So I'll not go into the history. Well, we'll not go back too much, but we'll start from C. Okay, so what used to happen in a C is always called a procedural level language, right? So when somebody writes the program, they used to write it this way. I have some small program copied from the internet. So if I have to add two numbers, what I used to do is we used to start with a main function, and we used to declare these variables, number one, number two, and the response. Yeah, we used to enter it from your input device. When you enter it, this used to be accepted, and then we would send it to a function, call function sum with two parameters, right? Number one and number two, and there is a separate function here. So it's very important, guys. Understand this. In programming word, these all terminologies are very important. Function, sometimes it is called a procedure. Okay, sometimes it is called subroutine. If you go into the ETL word, they call it as procedures. Okay, in C word, we call it as a function. In Java word, we call it as a method. Okay, but they all mean same. It is an abstraction of a certain unit, where certain kind of processing happens, where you write something, you do something, and you get something out of it. Okay, it's that kind of function. Okay, it does some function. Okay. I mean, it is everywhere. You might have used it everywhere. For example, you use Excel sheet. There are so many functions written, right? For you to sort the data, order the data, add the data, delete the data, find the duplicates. Many functions are there. Okay, in Excel sheet. So Excel sheet is also written with certain programming, right? They have used .NET for that. So it's the same thing. That application beneath, there is a technology which is have written the functions, and you see Excel sheet and as an UI. Okay, most of us would have used Excel sheet. Yeah, so likewise, this is the function. So see here, this is a procedure, this is a function. They, for them to logically separate it out, right, they could have very well written this logic inside here itself. Okay, but then they separated it out as a subroutine. You can call it as a subroutine, or you can call it as a procedure, function, method, but in C it is generally termed as a function. So they made it as a separate function. They could have very well done it here, but then they made, so this is a procedural language, and whenever you want to do something separate, which could be little reused, you make it as a separate function, so separate procedure. So from here you call it. Okay, so this is where it became very famous. Lot and lot of programs are still running on C. But then people realized that yes, this is definitely a good way of doing the programming. But then in procedural language, what used to happen is the number of lines of codes used to become bigger. The file containing the code would become eventually become very bigger. Okay, and it was not helping them to map with the business functionality. Okay, so we'll come to that. But then they wanted something in the real world. When the application started evolving, when internet came in, when software started evolving, so they wanted more of an real world classification. Okay, for example, they would want to see the entities. So think from this perspective, business perspective. Okay, there are lot of entities are involved. So you have you are in a college and you want to build an application for yourself. So what all entities come in? Teacher will become an entity, student will become an entity, your college will become an entity, exam will become an entity. Okay, and then your staff becomes an entity, your facilities, school facilities become an entity, your library will become an entity, your application filling will become an entity. Different entities, right? So these are different units. These are these are real world entities, which if you have to write everything in a C, you can imagine, how big that would be. It would not be very easy for anybody. If you are a master of C, you could very well write it. But if I come in new, I'm learning C, and I'm supposed to maintain this program after you go, then it becomes so difficult for me to read this, because you would have thought it. So I cannot really map the programming with the what to say, real world. So that is where your Java came in very handy. We'll see it with an example, but for now, for this functionality, right, just to add to some, you see this, you have something called here, there is we have made a class called add. Okay, so of course in Java everything starts with a class. We'll talk more on a class, but then there is a method. Everything starts with a main. There has to be a method somewhere. In C also it starts with a main, here also it starts with a main. That's a starting point of any programming language, right? There has to be some function, okay, called main. That is where it starts. So from here we are taking few inputs, and then we are calling somewhere below. I cannot go, can I don't think I can scroll below. But then somewhere below we have called that this method, okay, for us to print here, enter first number, enter second number, then we are calling this method, so that we get it. So here also typically same, not very different, but we have made them as two separate class. Here it is in the same file, but here these two are separate, two separate class files, class add and class add it in calculator, something like that. Okay, so basically what you did is you are bringing in more abstraction, because the program is going to become a bigger. The real world applications, when you write it for an enterprise, big enterprise, the program becomes bigger. You take any institute, okay, you go to any what to say, let me write it down. You go to any business. Okay, so generally how the businesses are there. So businesses will have a consumer who will consume the products. Okay, and you will have many products as a menu, right? So they will subscribe to one, so business, he becomes a customer. Okay, and then there will be your product. Okay, and then there will be services to the product, and then there will be an account. Okay, and then there will be what, billing for your account. Then there will be tickets or complaints. Yeah, and then there will be an order. Then there will be terms and conditions, and then there will be an what else, many things, I'm just quoting it at a very high level. Inside customer, you will have many things. You will have an address as an entity. You will have segment that kind of customers where they fall into certain. So many things, where you could it is up to you, right, as a designer, or as a programmer, you can bring them to any abstraction level. So for all these, I can make them as a separate class. If I had done it in a C, I would have written all of them into one thing. Okay, so it C basically the object oriented programming, right? These all become an object. I see the word as an object. Okay, so you may argue, why are you not seeing the word as a subject? But mostly more than a subject, it is an object, right? We make use of so many material things for our to lead a best comfortable life, right? But the subjects will be the people around us, more or less. They all function in the same way, but then what materials I'm using. So these are the things, that is why it was named as object oriented programming. Many objects. So we bring in the abstraction. So the whole point is, in C it was a procedural language. You would separate it in but then there was no technology or offering where you could keep extracting it, right, the way you want. But I want to classify them more. It's like a tree structure, I want to classify more and more and more, because I want to make it more readable. Wanted to make it more interpretable, comprehensible. Yeah, so that was the goal. So that is where the the class came into existence. They have named it so beautifully, right? Class, because they want to classify. They're making it a different class. Yeah, so they made it as a class. Okay, so they made it as a class. So let us see a simple class. Okay, so how do they define this class? So they make it as a class. I will say CPM. Yeah. Okay, so there will be some constructor. We'll talk about what is a constructor. Okay, so now the goal is to understand class, right? This constructor helps you to construct. We call them as instantiation. We'll talk about that. But so class is basically to classify. You want to classify certain things, so many things. So we saw the calculator example. We shall now see a different example. I have prepared one example just to give you more and more idea. So I have written a class called CPM class. Okay, simply a class. Don't go into the deep side of it. And I have many variables. So what is a variable, what is a function, will come to that in a while. So I just declared a variable. Okay, simple, team size, and so many, the object variables. Okay, you can we you can, for now you can say that these are the instance variables. So these are going to be the instance. Yeah. So what does CPM team constitute of? It talks to eSide, it talks to ETL, Kafka, Spring, Elasticsearch, Python, OpenShift Cloud, MDM, Oracle, Apache Spark, .NET UI, JSF UI, Unix, Ruby, and many more, right? These are the technologies what we make use of to build an MDM solution. So as we said, always the program starts with the main program, right? So let us go to the main program. So I have a program here. So what does this program do is simple. This program starts, and it goes and goes to a respective technology, and it tries to get what that technology has to offer, what it is special for. So there is a main function here. So we wrote a class main. This is starting point, this is the constructor. And from a main, we are instantiating the object of CPM. So you see, this is equal to new CPM. When we do new CPM, what it does is it creates an instance of CPM. We could have very well created another CPM object. Okay, it's something like CPM new. Okay, so what it does is, now we have two CPM variables, two CPM instance variables. Okay, so or two CPM objects, you could say, CPM and CPM new. So both will be while doing this, when you do new CPM, it goes and allocates certain memory because it needs to function, right? So when you create new, it needs to, so as a programmer you should create the new objects only when it is needed. Or if you could make you could really do everything with CPM, you should not definitely create another one, because it is unnecessarily going to hold the memory for some certain period of time. Okay, so these are the two instance variable. This is called instantiation. This process is called instantiation, allocating the memory onto the object, right? So now you are going to make use of this, and then and this is pointing, right, equal to sign. So this CPM becomes a reference variable. It is a reference to that pointer object, the object in the memory. It is address of that object in the memory. So it is called reference variable, and it is also called an instance variable. There are two instances, and these are the references. These two are the references. Okay, so and then I just simply write cpm dot team size. What is that? It prints for me. If you see, if I go to cpm, team size is 160 plus. Okay, and then I just I see generally the way you talk in classes, right, it is always through method. So there is a cpm class. Okay, and in the cpm class, there we if you see here, we have done, I am going to talk this class is something which always does something, right? It will have its state, and it will also have its behavior. So it will be doing something. If I have created a class, means it has to do something. Sometimes if it is not doing something, we call it as a plain old Java object. It will just be an object to hold the data. Okay, we'll talk about that also. So if there is something, then it will have methods. It will do something. Okay, so cpm dot, I'm calling the method. Just dot is something, you have this class cpm, you instantiated, you were calling with dot. You can call the variables, you can call the methods of it. Okay, so you call this method, you are passing an input to here to get that result, get functionality. What is that you are passing? You'll pass it as an elk. Okay, and then when you get it, when you get a result, if you see, this result is also, you're getting return. In return, you are calling this, and it is responding you this. And then that return, on top of that, that is also an object, and on that you are getting certain get specifics. Okay, and that you are catching it as a string, and eventually you are printing it. So let us go into this get functionality, what it is doing, right? Okay, I have not written the get functionality. Is there a method? Okay, let me go to the other classes now. Okay, so cpm java class. Okay, so cpm java class, here there is a get functionality. I have written this function. So string technology, it is offering, okay, if your technology is elk, and then I will open this elk also. I have defined it as another class. Okay, we'll see that. So I made an instance of elk. See, you called from your main class, you called your cpm class. From cpm class, now you are calling inside that method, you are calling an elk class. Elk, once again, it is giving you the core functionality, and it is returning that. Once, okay, there is no return function. I will return it as an object. Okay, so it is returning an object. So if the technology was Kafka, it is going to return that result. Okay, so this is the cpm java class for you. And then we will now go to the, what is it you are calling, the elk class, right? So I will call the elk class now. Okay, you see this, in the elk class there is a method. Elk is famous for, yeah. So here we took this method, yeah, and we are just printing is elk is famous for search engine. So that method what we were calling there, it is, maybe the method is not same. I think it was get functionality. We could make that get functionality only here. Okay, so you passed that, and it is returning you can what is it returning? Only string, right? We can return a string. Okay, I can return a string. I can return something called this. I will return this. So the whole idea is, this is offering you the great level of abstraction. Yeah, you are abstracting the data. The way you want, right? You can design it. It is giving you a beautiful capability. You could have very well written everything into one class, but then you can design it. How you design it? You think from an user perspective, more real world perspective. So I will give you an example. Okay, after this I'll just repeat on this example, and then we will go to the new example. So I just wrote a main class. The goal of this main class was to get the functionality as per the technology, what each technology does, right? I had written a CPM class. Inside CPM class we have a reference of so many other variables, and then in from CPM we are trying to get the functionality. We are getting and we are passing the arguments. Yeah, what it is, we sent in an elk. Let us assume I typed in an elk. So let me go to the CPM class here. So inside CPM class get functionality, we went in here for elk. We are going for elk and get core functionality. Okay, so inside elk it is a get core functionality. It is returning that, and I will now go to elk class. Here I will get core functionality is the method. Okay, so here we pass it as elk, and it is returning as elk is famous for a search engine. So I abstracted it at a 3 level. So you can abstract it at a nth level the way you want, right? For specific need you make a specific class and call that class. So that is the whole intention. Yeah, so now coming back to this. So so this is the beauty of Java. You get that object orientation. Everything, anything you make it as an object, you call it as an object. Yeah, so that is about an object. What you learned is what is a class, what you learned is an object. So in the runtime, when is actually it is working, right? When you as a developer, you write the code and you deploy it and put it in the runtime for execution, and somebody runs your program. Whenever, as and when the flow of the code goes, right, it keeps creating the objects, destroying the objects. So your class actually becomes an object. Okay, and then when you are writing many, you what you have written one, let us assume you have written an employee class. Okay, there is a big ERP application, you are working for a big company. Let us assume you are working for E&Y. Okay, E&Y, Ernst and Young company, right? So there, you were asked to build an ERP tool, enterprise resource planning, for you to resource for them to manage their resources, right? Employees. So they will say build an application like D360. Okay, where you fill your timesheets and all. So they ask you to build all that. So what you do is, first you will, as a designer, what you will think is, okay, what are my entities? Okay, how will I make my programs? Okay, what you will say is, oh, I will have to first think as an user who logs in. I will have features like timesheet. Okay, and I will have features like documents, policies. Yeah, inside a timesheet I will have something like leave management. Yeah, policies, and then I will have announcements. Okay, and I will have role based view. I mean, depending on your role, you will see so many things. We'll see reports, so many more things, right? How you do. Yeah, induction grievances, many things. Yeah, salary slips, many things. So these are all different entities you define, and then what you say, oh, okay, let me make a classes out of this, because user, in on all the page, if you make a class called user. Okay, you will have username. you know you will make it as a private, because you do not want people to hack it. So you will make a private, and you will make a method to somebody to set that. When you log in, you give your employee ID, it will set your username. Okay, when you give your username. Okay, and it will set your password. It is called data encapsulation, user password. Okay, you don't want people to directly access your username via variables, rather access them. So you declare them private, they cannot access it directly, rather they have to go via variables. Okay, if they have to get it, they have to really do a function called hackers cannot really directly take it, right? If they get hold of your class objects, they can easily. But if it is inside function, then you encapsulate it, you embed it inside. So that is why that is encapsulation. And then user, likewise timesheet, document. So you make this, and then this user object, when you create, if you log in, an instance of your object will be created. I have also logged in, you have also logged in. So two instances of user will be there, and they would be required on all these different pages. Okay, the user object is required to show it on the top, right? Employee name, So here there will be something called employee name. Username is fine, employee name. Okay, employee ID, the different variables. Okay, so these are required for all these pages. So you can think about it, right? You're not writing it as one, but this is simple one. But think about big enterprise applications, their entire program. You see the data models, right? You in CPM also, if when you see the data model, there is so many: contact table, contigu table, you have address table, location group table, you have contact method table, identify table. All eventually will become the objects. Very simple. What you think, pursue from a business perspective, what you think from a design perspective, data model perspective, everything, each and everything will become a class. Okay, it's very simple. Not it's just that you are bringing in that abstraction. You are thinking from a designer's perspective, how I design an application. So that is where this comes in. And then you want to make certain mathematical functions, you make a different class. You want to access the database, that you make different layers in your applications, right? You want to do the first, you want to do the authentication. You want to authenticate, that is a function of your application. You will have a certain classes for this. You want to bring in rich UI features, beautiful images and all, you make a different class sets where you can access them. And you want to make read and write access to database, you make a different class. You want to send an email to many people, you write a separate. The abstraction is not only for the real world entities, right? You real world entities, you do the abstraction for that. You do the abstraction for the functions, what you want to do inside, the operations, what you want to do different operations. So this is where Java comes in very handy. Okay, so what we learned, learned about a class. In the runtime it becomes an object, and then it becomes many instances. Okay, because if people call them many times, if I have logged in, you have logged in, there are two instances of the same object. So we learned about, I'll just repeat before we close this session. We learned about a class, y class. Okay, we learned about an object. At runtime it becomes an object. When you're running the program, it becomes an instances, many instances. When many people, a couple of users use the same class, you wrote one class but many people are using, we understood reference variable. So because it is referencing to a certain memory location, so it becomes a reference variable. We talked about data encapsulation. You encapsulate the data, you declare your variables as private access modifiers. And then we spoke about method. We don't I mean, everything, anything in the class is actually called by a method. You want to communicate from one class, you want, because you are abstracting it, right? So it starts with the main method, and then your goal is to get the data from database and send it to the UI. So then it goes to the series of hundreds of classes, goes and connects to database and gets the data. So that is why there are, I mean, lakhs together classes are written, the packages are written. So when you write, for some module you want to do something, authentication as a function. So somebody would have written a package, they would have written tons of classes just to authenticate, tons of classes, ready-made classes. They will, so you need to call the package, and inside that you will need to call that class. And then you want whatever result you want to do, you need to call that method, to get your job done. Okay, so it is so reusable, right? You can reuse it and get it done. So and then there are so many features. I don't want to talk about it. Inheritance, what you do is, you call simple, you inherit from your father, right? So you write so many classes, you write some class called inherit or whatever, and then you just call this class. All the methods and functionalities you extend your class with the super class, right? All the methods which are available in this class becomes a part of your class. So it is very easy, you need not have to write it. I, as a designer architect, I will make many classes. I, as a designer, I will write many methods, and I will creep it a framework, and you just call my class and everything will be ready for you. And then there are abstract classes. where it helps you to abstract the way the designers want to mandate you. There is an interface. I maybe in some other session I'll talk more on it. Interfaces are just where we want to mandate you to write the classes in a certain way. So that is how you do it. Yeah. So I think that's it for now. If any questions, please ping me. I would definitely love to hear a lot of feedback. And the intention was to make the layman's comfortable. Hope I will be able to convince the information. But then with the feedback, I will see if we have to talk more on it. Okay. Thanks for watching. I hope you like this video. Thank you. Bye bye.